Hello students, welcome to this lecture 1 Introduction to Trigonometry. So in this lecture we will discuss trigonometric ratios of some specific angles and there we'll discuss some examples. Okay, so let's get started. So from geometry you are already familiar with the construction of angles 30 degree, 45 degree, 60 degree and 90 degree. So in this section we will find the values of trigonometric ratios for these angles and of course for also 0 degree. Okay, so here some specific angles like 30 degree, 45 degree, 60 degree and 90 degree and 0 degree also. Here we find some we'll find values of trigonometric ratios, okay, for these angles. So let us find. So here we consider this right angle triangle ABC and here right angle at point B. Okay, so here if one angle is 45 degree, then the other angle is also 45 degree. That is angle A, this is equal to 45 degree, and angle C, this is also equal to 45 degree. Okay, so here you can see the BC is equal to AB. Okay, so BC is equal to AB. Since their corresponding angles are equal, so their corresponding this side and this side actually equal. So suppose BC is equal to AB is equal to A, and now by Pythagoras theorem AC square is equal to AB square plus BC square, that is equal to A square plus A square, this is equal to 2A square. Okay, so therefore the value of AC is equal to A times root 2. So AC is equal to A times root 2, and here the length of A is equal to A, length of AB is equal to A, and length of BC is equal to A. Okay, so using the definition of trigonometric ratios, we have sine 45 degree, this is equal to side opposite to angle 45 degree by hypotenuse. Okay, so here side opposite to angle 45 degree is equal to BC and the hypotenuse is AC. So sine 45 degree is equal to BC by AC, and here the length of BC is equal to A and the length of AC is equal to root 2 times A. Okay, so now this is equal to 1 by root 2. So sine 45 degree is equal to 1 by root 2. And now come to the cosine of 45 degree. So cosine of 45 degree is basically equal to side adjacent to angle 45 degree by hypotenuse, that is equal to AB by AC, and this is equal to A by A times root 2, that is equal to 1 by root 2 also. Okay, and tan 45 degree, this is equal to side opposite to angle 45 degree by side adjacent to angle 45 degree, and here this is equal to BC by AB, and the length of BC is equal to A and also length of AB is equal to A, so this is equal to AB A by A. Okay, and this is equal to 1. So tan 45 degree, this is equal to 1. And also cosec of 45 degree, that is equal to reciprocal of sine 45 degree, so that is equal to 1 by sine 45 degree, and this is equal to root 2, since sine 45 degree is equal to 1 by root 2. Okay, and sec 45 degree, this is actually reciprocal of the cos of 45 degree, and cos of 45 degree is equal to 1 by root 2, so sec 45 degree is equal to root 2. Okay, and now cot 45 degree is equal to reciprocal of tan 45 degree, and here the tan 45 degree is equal to 1, so cot 45 degree is equal to 1. Okay, so now trigonometric ratios of 30 degree and 60 degree. So now let us calculate the trigonometric ratios of 30 degree and 60 degree. Here we consider an equilateral triangle ABC. Okay, so we here consider equilateral triangle ABC, and since each angle in an equilateral triangle is 60 degree. Okay, so therefore angle A, angle B, angle C are all 60 degree. Okay, so now draw the perpendicular AD from the point A to the side BC. Okay, that is shown in figure 8.15. Okay, so now triangle ABD is congruent to triangle ACD. Why here this side is common to each other, and this angle and this angle are equal, and this angle and this angle are equal. So angle side angle by angle side angle angle side angle congruency property. By that property we can say triangle ABD is congruent to triangle ACD. Okay, so therefore BD is equal to DC and angle BAD is equal to angle CAD, that is corresponding parts of congruent triangle. Okay, so that is why angle BAD is equal to triangle CAD. So now observe triangle ABD is a right triangle. Okay, so here right angle at point D with angle BAD is equal to 30 degree and angle ABD is equal to 60 degree. Okay, so that is shown in figure 8115. So as you know, for finding the trigonometric ratios, we need to know the length of the sides of the triangle. So let us suppose AB is equal to 2A. So length of AB is equal to 2A. So now here then BD is equal to 1 by 2 BC and this is equal to A, and AD square, this is equal to AB square minus BD square, that is equal to 2A whole square minus A square, and this is equal to 3A square. So therefore AD is equal to A times root 3. So the length of AD is equal to A times root 3, length of BD is equal to A, and we have let the length of AB is equal to 2A. Okay, so now sine 30 degree is equal to BD by AB, and here the length of BD is equal to A and the length of AB is equal to 2A. So this is equal to A by 2A and this is equal to 1 by 2. Okay, so sine 30 degree is equal to 1 by 2. And now cos 30 degree, that is equal to AD by AB, and here the value of AD is equal to A times root 3 and the value of AB is equal to 2 times A. So A times root 3 by 2A, that is equal to root 3 by 2. So cos 30 degree is equal to root 3 by 2. Okay, and tan 30 degree is equal to BD by AD, and this is equal to A by A times root 3, that is equal to 1 by root 3. Also cosec 30, this is equal to reciprocal of sine 30 degree, that is equal to 1 by sine 30 degree, this is equal to 2, since sine 30 degree is equal to 1 by 2. Okay, and sec 30 degree is equal to 1 by cos 30 degree. So we have cos 30 degree is equal to root 3 by 2. So sec 30 degree is equal to 2 by root 3. And cot 30 degree is equal to 1 by tan 30 degree, and this is equal to 1 by 1 by root 3, that is equal to root 3. Okay, and now similarly sine 60 degree is equal to AD by AB, this is equal to A times root 3 by 2A, that is equal to root 3 by 2. Okay, and cos 60 degree is equal to 1 by 2, tan 60 degree is equal to root 3, and cosec 60 degree is equal to 2 by root 3, and sec 60 degree to 2, and cot 60 degree is equal to 1 by root 3. Okay, so now here we discuss trigonometric ratios of 0 degree and 90 degree. So now let us see what happens to the trigonometric ratios of angle A if it is made smaller and smaller in the right triangle ABC. Okay, so that is shown in this figure. So this is our right angle triangle, and here the right angle at point B. So till it becomes 0, as angle A gets smaller and smaller, the length of the side BC decreases. So length of this side will decrease. The point C gets closer to the point B. Okay, so and finally when angle A becomes very close to 0 degree, then AC becomes almost the same as AB. So in that case AC will almost equal to AB. So now here you can see this figure. Here when you decrease the angle towards 0, then here the side AC will almost equal to AB. Okay, almost equal to AB, and the point C will coincide with the point B. Okay, so when angle A is very close to 0 degrees, then BC gets very close to 0, and so the value of sin A is equal to BC by AC and is very close to 0. When angle is very close to 0 degree, then AC is nearly the same as AB, and so the cos A is equal to AB by AC and is very close to 1. Okay, so this helps us to see how we can find the values of sin A and cos A when A is equal to 0 degree. Okay, so we define sine 0 degree is equal to 0 and cos 0 degree equal to 1. Why this happen? Because when angle A is very close to 0 degree, then BC gets very close to 0. Okay, and then the value of sine A, that is equal to BC by AC, and here the value of BC is very close to 0, then the trigonometric ratio sine A is equal to almost 0. Okay, and when angle A is very close to 0 degree, then AC, this side, is nearly the same as AB. So the value of cos A, that is equal to AB by AC, this is very close to 1. Okay, so that is, we define sine 0 degree equal to 0 and cos 0 degree equal to 1. And now using this, we have tan 0 degree is equal to sine 0 degree by cos 0 degree, that is equal to sine 0 degree, that is 0, and cos 0 degree of 1, so 0 by 1, that is equal to 0. Okay, and cot 0 degree, that is equal to 1 by tan 0 degree, and here tan 0 degree is 0, so 1 by 0, that is, which is not defined. Okay, and sec 0 degree is equal to 1 by cos 0 degree, this is equal to 1 by 1, this is equal to 1. And cosec 0 degree is equal to 1 by sine 0 degree, and we have sine 0 degree is equal to 0, so 1 by 0, this is not defined. Okay, so now let us see what happens to the trigonometric ratios of angle A, what is made larger and larger in triangle ABC till it becomes 90 degree. So as angle A gets larger and larger, so angle C gets smaller and smaller. Okay, so therefore, as in the case above, the length of the side AB goes one decreasing. Okay, and the point A gets closer to the point B. So point A gets closer to the point B, and finally when angle is very close to 90 degree, then angle C becomes very close to 0 degree. Okay, and the side AC almost coincide with the side BC, that is shown in this figure. Okay, so here when we made larger and larger when angle is made larger and larger in triangle ABC, then here the point A will almost equal to the point B. Okay, so in that case angle C becomes very close to 0 degree, and the side AC almost coincide with the side BC. Okay, so when angle C is very close to 0 degree, then angle A is very close to 90 degree. Side AC is nearly the same side of BC. Okay, and so sine A is very close to 1. Since sine A, this is equal to side of opposite to angle A divided by hypotenuse. Okay, that is equal to BC by AC. Okay, so here AC is nearly the same as the side BC, so sine A is very close to 1. And when angle A is very close to 90 degree, then angle C is very close to 0 degree, and the side AB is nearly 0. Okay, so cos A is close to 0. So we define sine 90 degree is equal to 1 and cos 90 degree is equal to 0. Okay, so now we do not you find the other trigonometric ratios of 90 degree. So why do not you find other trigonometric ratios of 90 degree? So you can find, of course you can find. So we shall now give the values of all the trigonometric ratios: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree in table 8.1. Okay, for ready reference. So here we given all values in this table. So here angle A, when angle A is equal to 0 degree, then the value of sine A is equal to 0, cos A is equal to 1, tan A is equal to 0, cosec A is equal to not defined, sec A is equal to 1, and cot A is equal to not defined. Okay, and when angle A is equal to 30 degree, then sine A, this is equal to 1 by 2, cos A, this is equal to root 3 by 2, tan A, this is equal to 1 by root 3, and cosec A, this is equal to 2, and sec A, this is equal to 2 by root 3, and cot A is equal to root 3. Okay, and when angle 45 degree, when angle A is equal to 45 degree, then sine A is equal to 1 by root 2, cos A, this is equal to also 1 by root 2. Okay, and tan A is equal to 1, cosec A is equal to root 2, sec A is equal to root 2 and cot A is equal to 1. Okay, so at 45 degree, for angle A is equal to 45 degree, sin A and cos, the value of sin A and cos A equal. And when angle A is equal to 60 degree, then the sin A is equal to root 3 by 2 and cos A this is equal to 1 by 2 and tan A this is equal to root 3, cosec A is equal to 2 by root 3 and sec A is equal to root 2 and cot A is equal to sec A is equal to 2 and cot A is equal to 1 by root 3. And when angle A is equal to 90 degree, then sin A is equal to 1, cos A is equal to 0, tan A does not define, okay, and cosec A is equal to 1, sec A not defined, and cot A is equal to 0. Okay, so now let us give a remark. So from the table above, you can observe that angle A increases from 0 to 90 degree and sin A increases from 0 to 1 and cos A decreases from 1 to 0. Okay, so now let us illustrate the use of the values in the table above to some examples. So we here will explore some examples related with this topic. So let us explore some examples. So in triangle ABC, here right angle at B, and here the length of AB is equal to 5 centimeter, and angle ACB this is equal to 30 degree, and here we have to determine the length of the side BC and AC. Okay, so let us solve it. So to find the length of the side BC, we will choose the trigonometric ratio involving BC and the given side AB. So since BC is the side adjacent to angle C and AB is the side opposite to angle C. Okay, so therefore AB by BC this is equal to tan C, that is 5 by BC is equal to tan 30 degree, this is equal to 1 by root 3, which gives us BC is equal to 5 times root 3 centimeter. Okay, so the length of BC is equal to 5 times root 3 centimeter. And to find the length of the side AC, we consider sin 30 degree is equal to AB by AC. Okay, and here we have given the length of AB is equal to 5. So by calculating this equation, we get the value of AC is equal to 10 centimeter. Okay, so note that alternatively we could have used Pythagoras theorem to determine the third side in the example above. Okay, so for finding AC here we can also use Pythagoras theorem. Okay, so that is AC is equal to square root of AB square plus BC square. Okay, and length of AB is equal to 5 and the length of BC is equal to 5 times root 3. So AC is equal to square root of 5 square plus 5 times root 3 whole square, that is equal to 10 centimeter. Okay, and now let us move to another example. So in this example we have this right angle triangle. Okay, so triangle PQR, right angle at Q, that is shown in figure 8.20. This is 8.20 figure. Okay, and PQ is length of PQ is 3 centimeter and length of PR is equal to 6 centimeter. And here determine angle QPR. We need to determine this angle and angle PRQ, this angle. Okay, so let us solve it. So we have given PQ is equal to 3 centimeter and PR is equal to 6 centimeter. So therefore sin R this is equal to PQ by PR, or sin R is equal to 3 by 6, this is equal to 1 by 2. Okay, and we know the value of sin 30 degree is equal to 1 by 2. Okay, so angle PRQ is equal to 30 degree, and therefore angle QPR is equal to 60 degree. Why? Because we sum of triangle is equal to the angle A plus angle B plus angle C, and here angle B is 90 degrees. So we also find this angle, and angle of QPR this is equal to angle of QPR this is equal to 180 degree minus 180 degree minus 30 degree, 90 degree minus 30 degree, this is equal to 60 degree. Okay, so the angle QPR is equal to 60 degree. So you may note that if one of the sides and any other part, either an acute angle or any side of a right triangle is known, then the remaining sides and angles of the triangle can be determined. Okay, so let us move to another example. So if sine of a minus b is equal to half and cos of a plus b is equal to half, and here a plus b lies between 0 degree and 90 degree, and here a strictly greater than b, then we have to find a and b. So let us solve it. So here, since sine of a minus b is equal to half, and therefore a minus b, this is equal to 30 degree. Okay, since sine 30 degree is 1 by 2. Okay, since cos of a plus b is equal to 1 by 2, therefore a plus b is equal to 60 degree, since cos of 60 degree is equal to 1 by 2. Now solving these two equations, solving 1 and 2, we get a is equal to 45 degree and b is equal to 15 degree. Okay, now so basically here in this example we use the value of sine 30 degree, that is actually 1 by 2, and cos 60 degree, this is equal to 1 by 2. And here we have given this condition 0 degree less than a plus b less than equal to 90 degree, and a is strictly greater than b, and we have to find a and b. So here we have given this equation, sine of a minus b is equal to 1 by 2. Okay, and here a plus b, this lies between 0 degree and 90 degree. Okay, so sine of a minus b is equal to 1 by 2. So sine of a minus b, this is equal to 1 by 30 degree. And since we know sine of sine a is equal to sine b, okay, and if we have acute angle, if this condition holds, then it implies a is equal to b. Okay, so a minus b, this is equal to 1 by 2. Sorry, a minus b, this is equal to 30 degree, and cos of a plus b, this is equal to 1 by 2, and we know cos of 60 degree is equal to 1 by 2. So here we get cos of a plus b, this is equal to cos of 60 degree, and we know if cos a is equal to cos b, then it implies a equal to b, that we have proved in our earlier in our previous section. Okay, so cos of a plus b, this is equal to cos of 60 degree, and it implies a plus b is equal to 60 degree. Okay, so we get here two linear equation. Okay, then by solving these two linear equation, we get the value of a and b. So a is equal to 45 degree and b is equal to 15 degree. You can register yourself and give subject-wise mock test on this site. Okay, and register yourself and ask any doubt regarding this video lectures or any subject doubt. You can join to this link. Okay, and here you can find how to videos, and you can also visit our official website is sathee.portal.ai. Okay, so I stop here this lecture. Thank you very much to all of you.